So, if you've been hanging around the worlds of AI or data science, you've probably seen the acronym GLM pop up. Seems straightforward, right? But here's the thing. Depending on who you're talking to, it could mean something completely different. So today, we're going to untangle this mystery and figure out which GLM is which.
So really, what on earth is a GLM? Is it some new, powerful AI that can write code and stories? Or is it a classic statistical tool that's been a bedrock of research for decades? Well, what if I told you it's both?
And right here, this is the heart of all the confusion. On one side, you've got general language models. These are the massive AIs you hear about in the news. And on the other, you have generalized linear models, a fundamental concept in statistics. We're talking two completely different universes sharing one very confusing acronym.
So here's the plan. We're going to crack this thing open. We'll start with the AI side of things, looking at a real-world developer drama. Then we'll explore a really fascinating limit that these AIs have. After that, we'll pivot hard to the classic statistical model. And finally, we'll bring it all together and see what these two very different tools actually have in common.
And look, this isn't just some funny little coincidence. Knowing the difference is actually super important, whether you're building AI apps or trying to analyze complex data. One GLM is busy generating stories, while the other is trying to explain the hidden patterns behind them.
All right, so to really get our heads around the first GLM, the General Language Model, let's dive into a story. It actually just unfolded last Christmas Eve, and it's a perfect little snapshot of how this tech really moves forward, not in the lab, but out in the open, driven by a super passionate community.
So picture this, a brand new, super powerful AI model, GLM-4.7, gets released. Developers everywhere are excited, they can't wait to get their hands on it, but there's a problem, a big one. The official release isn't compatible with their current systems. They can't just download it and press go.
And what followed was this classic open source scramble, right on Christmas Eve of all days. You can see it right here in the timeline from the developer forums. At 6 in the morning, a developer drops the news but warns that a patch is needed. By late afternoon, a popular version that someone else made is failing spectacularly. But by that night, success. The community pulls together and a working, even faster version is found, tested, and shared with everyone.
And I love this quote because it just captures the raw, no-nonsense vibe of this community. You get these really blunt warnings right from the people in the trenches. No corporate speak here, just, hey, everyone, don't use this one, it produces random garbage. This is literally innovation happening in real time, minute by minute.
And this is where all that holiday chaos paid off. Check this out. The standard method was getting around 28 tokens. Think of those as pieces of words per second. But with the fix the community found using a technique called MTP acceleration, they boosted it to over 37 tokens per second. That is a huge speed up. And they figured it all out in less than a day. Incredible.
Okay, so we've seen how people get these general language models up and running, but here's where it gets really weird. All of these models, every single one of them, share a bizarre hidden limitation. We're shifting from the problem of getting an AI to run to a fundamental problem with what it can write.
So today's AI models have these massive context windows. It basically means they can read and process a staggering amount of information at once. We're talking the equivalent of an entire stack of books. But here is the paradox. They can read a whole novel, no problem. But when you ask them to write something long, they just stop. They consistently hit this invisible wall right around the 2,000 word mark. The quality just nosedives, or they just give up.
So you got to ask, right? Why? If the AI is smart enough to understand 100,000 words of input, why can't it generate, say, 10,000 words of output? What's actually going on under the hood? And what researchers found out is pretty wild. The problem wasn't the AI's core ability. It was its education. The data used to train these models just doesn't have many examples of good long-form writing. They were never really taught how to write a long essay because they mostly just saw short answers and snippets. So to fix this, researchers came up with this really elegant method they called Agent Write. It's so smart because it just mimics how a person would tackle a big writing project. First, you tell the AI to just make a plan, a detailed outline, complete with word counts. Then, you tell it to follow its own plan and write the thing one section at a time.
And wow, the results were just incredible. This simple plan then write idea allows the exact same models to completely shatter that 2,000 word barrier.
They started generating these coherent, well-structured articles that were 10,000 words long, sometimes even longer. They basically just taught the AI some project management skills.
Okay, deep breath. We're going to do a complete 180 now. While one GLM is out there writing novels, the other GLM has been the quiet, steady workhorse of statistics and data science for decades. Let's switch gears and get to know that one.
So, a generalized linear model, the statistical one, is basically a super flexible version of a simpler tool called linear regression. Simple regression is great if you want to predict something like a house price. But what if you want to predict a simple yes or no, like will a customer churn? Or a count, like how many people will visit this website tomorrow? That's where the statistical GLM shines. And this is such a game changer because, well, standard models are really picky. They expect your data to look like a perfect bell curve. But real-world data is almost never that clean. It's messy. Generalized linear models let statisticians break free from those rigid rules and model all sorts of real-world situations.
So how does it do this? With 3 core pieces. First, you've got the linear predictor. That's kind of the engine of the model. But then it has 2 clever helpers. The link function acts like a translator, connecting the model's clean predictions to the messy reality of the data. And the variance function helps the model understand that the data might be more or less predictable at different levels. All right, so we have these 2 totally different beasts, both called a GLM. One is a creative writer, born out of massive neural networks. The other is a meticulous analyst, a pillar of data science. Let's bring it all home.
This table really just lays it all out, nice and simple. The AI GLM comes from AI. Its job is to generate stuff, and it's all about predicting what comes next. The statistical GLM, on the other hand, comes from data science. Its job is to model relationships, and it's all about explaining why things happen. One creates, the other explains.
But here's the really cool part. Even though they are worlds apart in how they work, at their very core, they share the exact same purpose. Both of them are designed to look at a complex, chaotic system and build a simplified model that captures the underlying patterns, whether those patterns are in human language or in numerical data. And that leaves us with this really big, fascinating question for the future. As the AI general language models get better and better at writing like us, will they eventually need to borrow from the other GLM? Will they need the rigor and the explanatory power of statistics to move beyond just mimicking us and to start truly understanding the world they're writing about?